Hi everyone, welcome back to the channel, and today we will discuss another problem of magnetism. And I have picked this problem from Sashibhushan Tiwari sir's book. It is question number 44 from level 3 of magnetic effects of current, right? So it's not a very tough problem conceptually or calculation wise neither, but still I have picked up this problem because it will test your basic understandings very properly, and that's also good for your preparation, right? You need to solve this kind of problems as well. So let's get started. A wire carrying current I is laid in the shape of a curve which is represented in plane polar coordinate system as r as function of theta is given. Obviously r equals to b plus c by pi times theta. For theta's domain is 0 to pi by 2. It is also shown on the figure. Here b and c are positive constant, and theta is the angle measured with respect to positive x direction in anti-clockwise sense, and r is distance from origin as per our convention. So we are asked to calculate the magnetic field at the origin due to the wire. Okay. So obviously the equation is also given in polar form, and we'll solve it in polar coordinates as well. So it will again test your polar coordinate understanding and the basic formula by Savart law, right? Because after doing lots of magnetism numerical, we sometimes forget the basic ones, and with the help of that basic formula it can be solved, right? No memorized formula or derived formula will help you in this problem. So that is also one motive to pick up this problem, right? So I've just shown the polar coordinate here again just to give you a good revision, that let's say it is one small element length of dl right here as I have shown, and it is at a distance of r from the origin, and the angle subtended by that radius line, or you can say that r vector. Let me denote this vector as r vector with positive direction of x is theta in anti-clockwise sense. So in polar coordinates what we usually do is two we take two coordinates. Sorry, I don't mean coordinates, I mean two dimension, you can call it, right? If we say in 2D Cartesian coordinate, what we say, we represent every point in x and y. In 3D we represent every point in x, y, z, and in polar coordinates we represent it r and theta, right? So we have taken two unit vectors basically. One is r cap, and r cap is in the direction of r vector, right? It is a unit vector in the direction of r vector. And another one is theta cap, or some write is a t cap also. Somewhere you can find t cap because it is the tangential component. Theta cap is the unit vector in tangential direction, or you can call as perpendicular direction to r vector. So r cap and theta cap are two unit vectors, and with the help of these two we can represent dl line segment, right? So basically what we will do in polar coordinate, we'll write, sorry, 1 minute, yeah, we'll write dl as dr times r cap plus r d theta times theta cap, because you can see that dl is a small differential length element. So we will resolve it into two directions, right? One is r cap and theta cap. So what will be its component in r cap? R is the unit vector, so its differential element will be obviously dr in r cap direction. And what will be the small differential element in theta cap direction? Is it d theta? No, that's the wrong concept. Usually what we do, that if we have to resolve dl in xy coordinates Cartesian system, we write as dx I cap plus dy j cap. So just analogously you can think that in polar we will write dl as dr times r cap plus d theta times theta cap, but that is absolutely wrong. So let me tell you why. So basically if we differentiate r we get dr. So what is the, let's say I am drawing another figure here. This one is the origin and this one is r. So if we go a small angle of d theta in anti-clockwise sense, what will be this arc length? This arc length will be r d theta, not d theta. So that is a small differential element in theta cap direction. That's why we write r d theta times theta cap, not d theta times theta cap. Or as I was saying, that if you differentiate r, you will get dr. Similar way you can draw the analogy that if this one is a r radius, let's say, and this angle is theta, so this arc length would have been r theta. So if you differentiate r theta keeping r constant, for small d theta this length will be almost r, right? So keeping r constant, if you differentiate r theta, you'll get r times d theta. So anyway, these all are the explanations of why am I writing dl vector as dr times r cap plus r d theta times theta cap. So I hope it's clear. So let me erase all these things. So wait. Yeah, we're done. So this is my dl resolution of dl in, yeah, this one was my resolution of dl in polar coordinates in terms of r cap and theta cap. So what is the basics of Biot-Savart law tells us? It tells us that dB for any, let's say for any current carrying element small dl which is carrying a current I, we are trying to find out the magnitude and direction, both obviously, of magnetic field, let's say dB, produced by this segment at a point here which is, let's say, r unit apart from dl length, and this vector is obviously r cap as per our convention. Sorry, not r cap, r vector. R cap is the unit vector, right? So we just write dl mu naught by 4 pi I times dl cross r. We usually write, why? Because let's say this one was our ideal element and this one was the point at which we are trying to find a magnetic field. So you usually take this vector as r vector, but here I have already shown the direction of r vector. So if we try to find the magnetic field at origin due to dl element here, so we'll go at the reverse direction of r vector. So that's why we have written dl cross minus of r divided by r cube, right? So this is the basics of Biot-Savart law. So now it's clear, I guess. So you can divide the numerator and denominator by r, the magnitude of r vector basically. So magnitude of r vector is r obviously. So if we divide by r, we'll get a r square in denominator and r vector will turn out as r cap, unit vector, and I have kept the minus sign outside. So this one was the resolution as I have already explained, times r cap. So r cap times r cap will obviously be null, and theta cap cross r. So just use the right hand thumb rule. I have not defined the k cap and minus k cap, so let's not get that much complicated. We just need the direction. So we'll show it with a symbol. Theta cap cross r is coming as into the plane, and there was one minus sign outside. So accumulating that minus sign, we'll get the direction as outward, right? And magnitude is obviously r d theta. Theta cap cross r cap will be unit vector in this direction, outward direction, right? I mean after accumulating the minus sign. So 1 r and r gets cancelled. We get mu naught I upon 4 pi as constant. And as the total, we are trying to find out the total magnetic field. We will do the integration over the limit of theta equals to 0 to theta equals to pi by 2. And this one was the function of theta, r as a function of theta given in our question. We have put that value here. And now it's a simple integration, I guess, right? This is a linear function in theta and denominator. So the integration will be ln of b plus c by pi upon theta, sorry, c by pi into theta. And we'll divide with c by pi or multiply with pi by c. We are putting the limits here, and it's a simple calculation. You will get this result. I am not explaining the calculation much. You can do it at your own, I guess. So yeah, that's all. And as I said, it is not conceptually very tough, or calculation is also very simple, but it will test your understanding of polar coordinates and Biot-Savart law definition, right? So that's why I like this problem, and I hope it's very useful to you as well. So thank you, and that's all for today.